Wait, hold on. Wait, where am I? I did it in Hello World, right?
The patient record
Yeah.
was
I did it here. Here, I'm just going to add another class because none of these guys have a main. Must have deleted something from this some previous point in time. That's fine. So we'll create a new class. Call this guy driver. Now, all I asked you to do for this question is write a method. You didn't have to write the whole class. So I'm going to write this method. Method's got to be called compare patients. You could use the static or not. It didn't matter since I just asked you to write the method. So I'm going to say static boolean compare patients patient record PR1 patient record PR2. Return PR1 dot get first name dot equals PR2 dot get first name and PR1 dot get last name dot equals PR2 dot get last name. So return, does the first guy's first name equal the second guy's first name, and does the first guy's last name equal the second guy's last name? Are they the same strings in terms of content? So that one was one line. Could have been one line. You could have asked if statements too. What's not correct is to say PR1 equal PR2. That compares the pointers, not the contents. You also can't say PR1 dot get first name equal PR2 dot get first name. This is the primitive type comparison. That compares primitive types. And this actually may work some of the time, depending on how your strings were built, but is by no means guaranteed to work, depending on how the strings were built. Okay, because if you were comparing string literals, and you pass in the string literal Mike to both of those, Mike does equal Mike. But if you created two strings, and we did this in class several classes ago, remember that? If you created two strings with a new keyword and they both equaled Mike, those would actually not be equal to each other with a double equal sign. So not the same string literal. All right, so bottom line is double equal sign is never appropriate for comparing strings in terms of their content, even though it sometimes will work under very certain circumstances. So until you completely understand what those circumstances are, and even then, it's never appropriate to use the double equal sign for comparing strings. Use the dot equals method. All right, questions on that one? So, one-liner. You could have stretched it out into more than one line. You could have said, if the first name of the first guy is equal to the first name of the second guy, then if the first name of the last name of the first guy and the last name of the second guy are equal, then return true. Else return false or something. So you could have made it more than one line very easily. Number 8. Write a method called replace vowels that takes a string as a parameter that returns a new string with all of the vowels in the original string replaced by question marks. Oh my gosh. The number of people that missed this. Where am I? Oh. Oh. So we'll create a string with all the vowels in it, create our answer to build up a new string, because whenever we need to change something in a string, we need to build a brand new string. Then we'll write a for loop to go through our entire input string S, one character at a time. We'll call the index of method on vowels, which returns a -1 if the character we search for is not there. So this says, get the character from S that we're currently looking at. If it is not a vowel, let's keep it. If I'm in this else, that means it was a vowel. And we're supposed to replace vowels in this, right? All the vowels in the original string replaced. Okay. So if it is not a vowel, that's what that first if statement says, then just tack on whatever the character is. If it is a vowel, skip it and tack on a question mark. Ultimately return the answer. So that's replace vowels. All right, question about any of those? All right, so that was the exam. If you, after class today, if you think I cheated you points or something, you can come up and haggle. But I want to talk about the homework assignment next. Okay. So we're going to create a brand new project, Java project, called Towers of Hanoi. And then I'm going to trick you. It's going to be just hilarious. We already have that up, right? Oh. I'm going to download our folder. What? There's only 4 submissions? Well, there's definitely less submissions than there are people in here. You guys are just killing me. What just happened?
Broke it.
I did just break it. Is that not my, oh, I did just break it. I'll have to fix that at some point. Users. I'll have to add it back. All right. Delete. So we're going to take all this crap that I gave you. Copy. Okay. So, this is what I gave you to work with. And you're supposed to implement the game Towers of Hanoi. Let me reset this. Assuming you have 3 towers and 3 discs. I gave you this website so you can come and play the game first. Hopefully all of you had seen this prior to this at some point, but if you didn't, it's not like it's difficult to understand. The goal is to get all of these discs from the first tower all the way to the last tower. All right? But there's a rule. You cannot put a larger disc on top of a smaller disc. So when you do your moves, For instance, we're not allowed to do that move because I can't put the larger disk on top of the smaller disk. All right, so that is a solution to that one. That happens to be the best solution for that. There's actually an algorithm for solving the best solution, but you didn't have to do that for yours. Your solution for this only had to mechanically make the towers work and then prompt the user for what's your source tower, what's your destination tower, make the move if necessary, blah, blah, blah. First problem. Well, first of all, I think at most, it might have only been one of you, but at most, 2 people asked questions about this assignment. And then 2 other people complained. They said, oh, we don't know how to do this. This is stuff we haven't done. It's freaking stacks. Okay, but here's the problem. Tell me, what's the difference between a linked list and a stack? I thought about making this a quiz, but I figured there would be enough torment today as it was. What's the difference between a linked list and a stack? Remember, I'm tricking you. Go ahead.
Well, from what we've done and what we have there, our
Well, like now you're getting all
stack-
defensive.
yeah,
Okay, yeah, I get it.
A stack is a linked list, but a linked list isn't necessarily a stack because stack extends linked list, and then we added push pop and repeat to it. Essentially there.
Okay, no. Nothing he said is incorrect, but it doesn't tell me the difference between a linked list and a stack.
Linked lists you traverse. For stacks, you typically work off the top.
Okay, no. This is the trick. Can you implement a stack using an array? Is it incorrect to implement a stack using an array? Remember we talked about linked lists versus arrays. I was very specific in saying that a linked list is not an upgrade to an array. Linked lists and arrays are very comparable, as question number 1 on the midterm asked, correct? There's a right time and right place for each of those. When would you use an array instead of a linked list? There's one very quick, obvious answer. Okay, that is a correct answer, but not the most obvious one. If you absolutely need it to be fast, go with an array. That's true. But what's the even more obvious one?
When you know the size.
When you know the size. You use an array 100% of the time if you know the size of the data you're storing. Because an array will always be better if you know the size. When do you use a linked list? Conversely, when you don't know the size. When you need to store an arbitrary number of things, correct? Linked lists and stacks are not comparable. A linked list is a material that could be used, is a structure that could be used to build a stack, as an array is a structure that could be used to build a stack. It's no different than building a house out of wood versus a house out of brick. Does that make sense? Why is it appropriate to build our towers, stacks, out of arrays instead of linked lists? Because you know they're only going to hold 3 disks. At most, right? Could you have implemented with a linked list? Sure. Could have. No harm, no foul. But you don't need to. So, that's the first lesson. Most important lesson out of this. Understand that stacks have absolutely nothing to do with linked lists. Stack is a problem-solving tool built on top of 3 methods. What question was that on the test? 4? Number 4. All problems involving stacks are solved in terms of push, pop, peek. Stacks are actually quite simple. Solving problems with stacks is where the complexity comes in. Making sure you push and pop stuff in the right order. Sometimes you use two stacks. So you pop stuff off one, push it over here temporarily, and so you can pop something else and push this guy back on. So it's the complexity of the problem you're solving with the stack tool rather than the stack itself. Because pushing something onto the top of a stack and popping something off the stack is actually quite easy. Substantially easier than when we wrote our general purpose linked list. Right? General purpose linked list was pretty convoluted because we had, we're going to insert stuff in the middle and remove stuff from the middle and insert stuff at the end. Stacks, you're only adding to the front, you're only removing from the front, and sometimes you just look at it. That's it. All right, so now that we got that part out of the way, and I promise I'm not contagious. Many days into my antibiotics. But I hope every one of you gets malaria. Well, no, hold on. I hope everybody that got less than a 70 on the exam gets malaria. So.
He just tells us that he took the antibiotics. This is his revenge.
I haven't taken anything. The second I started bleeding from my tear ducts, I'm like, oh boy, this is my opportunity. The funny thing is that same day, I was sitting at my computer at night and the movie Contagion came on. It was on, TBS? It was on like multiple times. It was alternating between 2012, The End of the World, and Contagion. Like they kept playing one, then I watched them multiple times. Because I had nothing better to do. I even was sitting on a bedpan. It's too late. I got pictures of that.
No, don't go for the Amish. They don't have that immunity.
They don't have antibiotics. They chew on tree bark or something. All right. So, the first thing that people complain about is, I just gave you this big directory of stuff to start with because that was easy for me to just zip all this up. Make sense? So all this crap is some extra crap. You know how like when we're working in class, I just keep adding classes to our folder? So I just gave you a bunch of classes. I didn't mean you had to use all the classes. Whenever you're presented with code, you have to figure out what the code is doing. Always start with main. All programs begin and end with main. What does main say? It says we're going to create an instance of this object called Towers of Hanoi, and then we're going to display it. Okay, so let's go and look at Towers of Hanoi. Towers of Hanoi is an object that has a single field, which is an array of tower objects. Here's the constructor for it. It's an array of 3 tower objects. 1, 2, 3. 3 tower objects. The first tower took in 3. The second tower took in a 0. Third tower took in a 0. That's the number of disks. Okay? Now let's go and look at our tower. So our tower has an array of disks that it holds on to. The array is always capable of holding 3 disks. We know the size of the array. We know the worst case is any one of our stacks, any of our towers, can hold 3 disks, right? But the constructor for tower, because the constructor is used to build the initial state of an object. Constructors are used to initialize objects. What's this guy for? You take in the number of disks, he builds the array with always capable of holding 3 disks, but then we actually fill it up with disks. How many disks? Num disks, number of disks. Make sense? Now this cur size thing I'm using to pass in to disk. And that just keeps track of how many equal signs wide the disk is. So let's go into disk. Here's disk. Doesn't even scroll. A disk keeps track of a single field, size. When you call the constructor, it takes in that size and it just sets that field equal to that value. Then we have a getter to get the size. This is simpler than patient record, right? And then we have this little toString thing that just returns a representation of this disk in terms of equal signs. All for display. All the code that's currently here is just for displaying stuff. Okay? And even the display method doesn't, because of the nature of the problem we're solving and not using graphics, you can only sort of get it to work so well. With more complexity, you can actually get it to work correctly if you make a bunch of assumptions that you only have 3 disks. But the generic solution I have in here looks great when you have a finished tower, but when you're in between, you get a little shifting. But you can still tell. You can still play it. So that's all the code you have to deal with. Now, so all a disk is a size and a way to represent itself. All a tower is a array of disks. But we know that whenever we pick, if I reset this, whenever we say I'm going to move something from this tower to this tower, let's say, we know that I always remove from the top and push onto the next tower. I remove from the top, push. Push too hard. Push onto this tower. I remove from the top, push onto this tower. It's a stack. Towers are stacks. Those are synonyms. Disks are what? In terms of our linked data structures nomenclature. They're nodes. Disks are nodes. Towers are stacks. Okay? So, we need to create the ability to pop something off of a tower and push something onto another tower. And what are we popping off? We're popping off a disk. In order to keep track of what we're pushing and popping, well, let's just deal with popping first. In order to keep track of how we pop off a tower, we need to always know where the top of the tower is. That make sense? So every single tower, we're going to add an integer to. Int cur top. And we're going to start cur top off at 3. 3, if our towers are arrays of size 3, legal buckets are 0, 1, 2. So 3 would be an illegal position, correct? So if we have a cur top of 3, that means it's an empty tower. If cur top is 2, that means we have a tower with 1 thing on it. If cur top is 1, we have a tower with 2 things on it. If cur top is 0, we have a tower with 3 things on it. That makes sense? Because that's our array, bucket 0, bucket 1, bucket 2. That is, if these are our towers, each one of these towers can hold 3 disks. The current top of this tower is 2. 0, 1, 2. That's the next disk I'll remove. The current top of this tower is 3. 3 means it's illegal. 3 would be down here, right? It's an empty tower. Current top here would be 1. 0, 1 would be the current top. But if we had a fresh tower, current top is 0. 0, 1, 2. Current top is bucket 0 of that array. That make sense? So we're going to keep track of cur top. Then, as we add disks, we'll subtract from cur top. So when I add 3 disks to a tower, cur top will go from 3 to 2 to 1 to 0. When I add 2 disks to a tower, well, just think about the initial state. So when I first start my game, and I create my 3 towers, the very first one I passed in 3, we created 3 disks of the correct size, the correct number of equal signs. And this guy went, cur top started at 3, then it became 2, 1, 0. But these 2 stayed at 3 because I didn't add any disks there. Make sense? So now I'm keeping track of the top of my stack for each of these guys. So let's write pop. So I'm inside tower. We're going to write public disk, because when I pop something off a tower, what's going to pop off is a disk. Public disk pop. And what's pop going to do? Well, if cur top is equal to 3, if this is an empty tower, let's just return null. I have nothing good to return for you, so I'll give you nothing. So I definitely don't want to access bucket 3 of a 3-bucket array, because that'll give me an array index out of bounds here. Otherwise, I'll return the disks at bucket cur top. But we have a problem there. If I pop something off there, cur top just moved, right? So I can't return it yet. I need to store it. So we'll store the disk, the current top. Then, if the current top was 0, the new top will be 1, correct? We have to add 1 to it. So we'll say cur top plus plus. Then we can return 10. That make sense? Now, we actually could have made this work. If you remember back when we talked about plus plus and minus minus, we could have just returned the disks at cur top plus plus. We could have done the plus plus there. Knowing that since the plus plus came after, then it would give you the disk at position cur top now and then increment cur top. But you never have to do that. You never have to remember whether plus plus coming first or after makes a difference. So this is the safe way. This is the safe way of doing it that will always work. Get the disk that I know I want. Change cur top, and now we can say plus plus cur top plus plus, cur top equals cur top plus 1, cur top plus equals 1. Choose your poison. Malaria, whatever. All right. And ultimately, return the disk. That's pop. Public disk peak. The reality is we can solve this problem without even using peak, but we'll implement peak since we're drilling arrays into your head, or drilling stacks into your head here. Peak. What does peak do? Well, actually, there's one thing we didn't do here. We actually technically don't need to do it, just for the sake of clarity, let's say. Up here, after I retrieve the disk, I'm going to say the disks at cur top is equal to null. I'll empty out that disk. After I grab the disk off the top of the stack, I'm going to zero out the disk that was there. Make sense? That officially removes it. But I have preserved it here inside of this variable called temp. Peak. Peak is pretty similar to pop, except we don't actually remove it. So here, I'll steal all this code. And then we'll whittle it down a little bit. If cur top is 3, return null. Otherwise, just return that guy. Because we're not adjusting cur top, we're not removing it, we're just letting them see it. Make sense? Okay, now, Push. Push is the complex one here. Because when we push something onto a tower, we need to make sure the rules are met. Okay? So we're going to make push in this case return a Boolean. And this guy's going to take a disk as a parameter. And we're going to ask the question. We're going to say if cur top is equal to 3, that means we have the empty stack. We don't need to check anything. We can just go ahead and add it. Right? So what do? We say cur top minus minus, because the new top will be at bucket 2. Then we'll say this dot the disks at bucket cur top is equal to D. And here I'll just go ahead and say return true here. Successfully added. Else, if I'm not dealing with the empty stack, then I know I have a stack that has at least one disk on it. I don't have to worry about the stack being full, because I know that each of my towers is capable of holding 3 disks, right? And I only have 3 disks that are being passed around. So the most disks I could ever have on one tower is 3. So if I'm pushing a disk onto this tower, that means at most that tower has 2. Make sense? So I couldn't have popped a disk someplace else if this tower already had 3 on. So I don't even need to check to see if the tower is full. So else, I need to look at the current top disk and find out if that disk is smaller than the disk I'm trying to. I need to compare the sizes of the disks. So what I'm going to do is I'm going to say disk temp is equal to this dot pop. Okay? Now, because I know I'm not dealing with the empty tower, I know for a fact pop will give me a disk. I don't need to check for it being null. Correct? Because I already did the question, is this tower empty? So if I'm in this else, I have at least 1 disk. So popping from it, no problem. So I popped from the tower. I should have peeked probably, but I'm going to do this with just push and pops. So we don't even need peek. So I'm going to pop this. Then I'm going to ask the question. I'm only allowed to push D onto this tower if what? If the size of D is smaller than the size of temp. Correct? Disk already has a method called getSize. So we'll say if D dot getSize is less than temp dot getSize, that means we are allowed to put it here. So what do? Then we say cur top plus plus. Actually, is that the right way? So the current top is 2, and putting something else on it, it's minus minus. Cur top minus minus. And then I'll say this dot the disks at bucket cur top is equal to D. Return true. Else, it's an illegal move. Return false. So that's push. If it's the empty stack, go ahead and add it. Otherwise, get the top of the stack. We're missing something. Give me a second. Get the top of the stack if we're allowed to add it. Great. Then we should add it. But before we add it, we need to do what? We need to push the current guy back on. This dot push temp That makes sense? We could have also just put it back at cur top. That would have worked. We could have also just used peak. That would have worked. So probably the most stack appropriate way of doing this would have been to say peak at the top of the stack. Then we don't have to push it back on there. So if we peak at the top of the stack and we're allowed to push something on top of it, then push it on top of it. Else, return false. If we popped it, then we would have to put it back in either case. We'd either put it back before we added the new thing, that way they don't get added in the wrong order, or we would definitely have to put it back. Well, we have to do that, or in the event that we were not allowed to add it, we at the very least would have need to push it back here before we end this method. But with peaking, we did not damage our stack to begin with. So that's the advantage of peak. We can just look at the top of the stack. Make sense? Look at it. If it's kosher, we can push something on top. Okay, so that's push. All the complexity of a stack is built into those three methods. Push, pop, peak. And now we understand what those three methods do. We can now use those methods to manipulate things. So we're going to go into Towers of Hanoi. And we're going to create a public void play method. And this method's going to go through that process of asking for the source tower and the destination tower, and us try to make that move. Okay? So we're going to say, well, let's just do this. While true, do it in an infinite loop right now. We'll change it in a bit. So we'll say we need a scanner to read something in from the user. So we'll need to import java.util. Okay? While true, what are we going to do? System.out.print. Enter source. And we'll do this as 0 base, so the very first tower will be tower 0. Then we'll say int source is equal to input dot next int. System.out.print, enter dest, int dest is equal to input dot next int. And if you use next line instead of next int, you would have just had to wrap that in integer.parseInt to convert the string to an integer. And for this case, we can assume that they put in, they don't enter things like Bob as the source. Okay? So we'll read in our source and our destination as numbers. Then we need to move. Well, so we need to write a move method. Public Boolean move. Int source, int dest. And it's going to return true if a move was possible and false if it's not. I have malaria. That's how bad this is. We're rating Towers of Hanoi here. I have malaria. For like a while. How sick do I still sound? Yeah, I've been gone for a week. Blood out of my tear ducts. I hate you people.
Nosebleed should have a party.
We know.
Seriously. Compare notes. Nosebleed and me. How's Nosebleed doing? He changed majors, didn't he?
Yeah.
Doing good?
Yeah.
We should grab lunch sometime. I miss Nosebleed. What was I doing? Oh, that's right. Well, you saw that picture on Facebook, right? With the Kleenex up my nose, and I had the video.
It was a great video.
The hold on. Those were not Kleenex. Those were paper towels. Now, it actually wasn't a full paper towel. My wife gets those, adjust the ones that you have like the multiple sizes. So it was like the small sliver paper towel. So it isn't as impressive. But I put an entire paper towel up each nostril. My wife was concerned that I had pushed it up there too far and I wouldn't be able to get it out. And you know you're done when an entire paper towel begins to drip. Then it's time to change paper towels. See, I would have rather come in and teach than that. So move. Move's going to take in a source tower and a destination tower, and it's going to try to do the move. Now, there's a bunch of conditions where a move is impossible. If source is less than 0, or source is greater than 2, or dest is less than 0, or dest is greater than 2, or source and dest are the same number. Those are all illegal moves, right? So if source less than 0, or source greater than 2, or dest less than 0, or dest greater than 2, or source equal dest. If any of those are true, return false. I'm not even going to try to make the move.
You missed straight line.
So I was testing you. I have malaria. All right. That's actually a good catch because that would have been something that might have been hard. That's it. I did do it on purpose. Okay? That would have been an interesting bug because that might have been very difficult to track down because technically that is not a syntax error. There is a such thing as a single bar. It's a bitwise OR. So it does OR at the bit level. So if you had two binary numbers, 101 and 001 or something like that, it would do ORs at each bit. Where if one or the other or both was a 1, it would be true. So it's actually a mathematical function. So it wouldn't have been a syntax error. It would have been difficult to trace down. So good catch. You get a half star for the day. Most of that's because he missed Hello World on the test. I was telling my wife as I was grading your test that I was glad that you missed that. No, it's actually, I mean this. Oh, I mean this very sincerely. You are far better at this stuff than what you score in the test, and you know that. But you're too cocky about it. So hopefully it humbled you a little bit, and maybe you'll pay a little bit more attention. Because I'm pretty sure if you had to do it again, you could probably write the test in your sleep.
Not only did I mess the system that out, that print line, I also switched string and arm.
Yeah, I'm quite aware. Not my first rodeo.
You didn't also catch my system that out that Printland missed there.
Well, those are less important because that was not, you didn't have to be perfect on those. I'm just saying that's the lesson you should learn from that score. It has nothing to do with competence. It has to do with cockiness and your ability to pay attention to what you're doing.
Well, Friday just wasn't a good day for me.
Yeah, that's fine, but understand that I'm well aware that you know what you're doing.
This doesn't say so.
But I know so. Two very different things, which is why I'm glad you did poorly.
Thank you.
Well, somebody needed to give you the wake-up call. That's true. You're a polarizing individual. Either people like you or they hate you.
Oh, I enjoy that very much.
Yeah, no, I get it. I'm the same way. I'm just pointing out why I liked giving you a poor grade.
Would you rather him yell at you or your paying boss?
I don't know.
See, you wouldn't get that level of candor from most professors, right? Like I belittle his religion. All right, hold on. Everybody relax. All right, so if it's an illegal move, we're going to return false. Not even going to try to do the move. Otherwise, we will return this dot, the towers at bucket source dot pop. That's the guy we're going to try to push onto this dot, the towers at bucket dest dot push. Okay? But we cannot just return it. We need to store it first, because in the event that it did not make the move properly, we got to put the other disk back. Make sense? Okay, so we need our disk temp is equal to the pop. Then, if the push worked, if we successfully pushed, then return true. We're done. Else, this dot, the towers at bucket source dot push temp. Put it back where we got it. Put our toys away. Make sense? And we don't need to check this. We know it'll work. We wouldn't have been able to pop it if it wasn't previously pushed there. That make sense?
In your conditional, wouldn't it be better to have source is greater than or equal to dest?
Well, you mean with this one?
Yeah,
Source is great.
because you can't have the destination be bigger than the source.
Sure you can. You could pick from tower 2 and move it to tower 0.
I'm thinking size.
Yeah. Right. These are tower numbers. These are indexes. I get what you're saying. Yeah, our push method handles that logic. All right, so this allows us to make moves. So we return false here, we return true here. If we have to put it back, we return false. Okay? So that's our move. So what we'll do inside of Towers of Hanoi, inside of our play method now, we'll read in source, we'll read in destination. Well, the very first thing we should probably do is we probably say this dot display. Show them the current grid. Read in source, read in destination. Then this dot move source dest. And we should see the screen update. We'll just do this forever. So as of right now, we should be able to have the ability to move disks around and then see it detect whether it's legal or illegal. So there's our starting point. Oh, hold on. I don't actually call play yet. Driver. So enter source. We'll pick 0. And let's pick our destination as 2. We saw it move from 0 to 2. See how things get a little less good looking then. Then we're going to pick 0 to 1. And we'll pick 2 to 1. Then we'll pick 0 to 2. Then we'll pick 1 to 0. 1 to 2, 0 to 2. But now, we're not detecting the finish yet. But now let's see some illegal moves. So let's go 2 to 1. Then we're going to go 2 to 1 again. And it should not let us do that move. It should show the state as it currently looks. Because we're not allowed to put this larger disk on top of the smaller disk. That was an illegal move. We also can't do 2 to 2. We can't do 5 to 2. We can't do 2 to 5. So on and so forth. Make sense? So right now we have the ability to move our disks around at the very beginning of it, because we're done right now, right? This class is end at 20. Okay. Very beginning of class next time we're 5 lines of code away. We're just going to count the number of moves and detect when tower 3 has a cur top of 0. Because that means we're done. So a couple if statements and we're done with the whole program. Make sense? So, things you want to take from today's class. Stacks don't have to be linked lists. And the way you look at given code is start with a main method. That tells you what things are being used. Make sense? All right. I'll see everybody on Thursday? Thursday.
Don't go to Iowa. You'll get African diseases.
And if you do have a question about how I graded your exam, do come up and I'll tell you why I took off what I took off, or if you deserve points back, I'll give you points back.
So instead of using stacks,